Hey guys, this next video is going to start our second unit of study over quadratic equations. In this second unit, we're going to actually be talking about how to solve all of our equations by hand or algebraically, as opposed to using our graphing calculators and using the different analyze graph features. Okay, so I still want you to get in the habit of using your graphing calculators to check a lot of your answers in this unit, but now we're going to go through and we're going to talk a lot about your different handwritten ways of solving all these equations. So to begin this unit, I just want to briefly review the process of factoring. That's something that we did last year, but I just want to go ahead and refresh your minds on some of those processes and concepts. So this entire first section here is going to be all about factoring. So what I want you to remember from last year, first of all, is this. Factoring is basically just reversing polynomial multiplication. And so last year, we first started out our study of polynomials by getting problems kind of like this, okay? Like the quantity x plus 4 times the quantity x plus 2. And we learned that you multiply polynomials by distributing each term in the first polynomial to each term in the second, okay? And a lot of times we use the acronym FOIL to talk about how to do this. And so we would go through and do x times x, which is x squared, and then x times 2, which is plus 2x, and then 4 times x, which is plus 4x, and then 4 times 2, which is plus 8. Combine your like terms in the middle, and you get x squared plus 6x plus 8. Okay, so that's what we started out doing. And then, after we learned how to do that, we talked about how to factor, which is basically going from this form, okay, back to this form here. And so, in this unit, we're going to be reviewing how you go from a trinomial like this or a different polynomial, something that looks kind of like a standard form expression, to something in this form, which is called factored form. Okay, so we're going to review those types of problems today in this section. So the first thing I want to talk about is how we factor binomials. Okay, so if an expression contains only two terms, then we call it a binomial. And if you see a binomial, you're going to try these two different factoring methods. Okay, these are the two methods you're going to try for binomials. First, we always try to factor out a GCF. Okay, no matter what. We always try to factor out a GCF. So if you're given the binomial 6n squared plus 9n, think about, is there a GCF of 6 and 9, first of all? And there is. Its GCF is 3. And then n squared and n, you can factor out a single n from each one of those. Okay, so we would say the GCF of this expression is 3n. And so then if we factor out a 3n, we're going to be left over with the quantity 2n plus 3. Okay, because 3n times 2n gives us the 6n squared up here, and 3n times 3 gives us the 9n. So this is how you factor that expression 6n squared plus 9n. This would be the factored form here. Okay, the other method for factoring a binomial is by using a difference of squares. And so if you have the expression 25x squared minus 49, you'll notice that 25 and 49 are both perfect squares. Okay, and this is a difference problem, so this is therefore a difference of squares. Since there's no GCF for this problem here, my rule for factoring a difference of squares is to take the square root of my first term. The square root of 25x squared would be 5x. And then the square root of my second term, square root of 49 is 7. And to put it down in this format, the quantity 5x plus 7 times the quantity 5x minus 7. Okay, and if I wanted to check myself for that one, I can just FOIL that out. 5x times 5x is 25x squared. 5x times negative 7 is negative 35x. 7 times 5x is plus 35x. And then 7 times negative 7 is negative 49. Your negative 35x and your positive 35x cancel out, and so that's why that works. Okay, you get 25x squared minus 49 when you check that. So this would be the factored form of 25x squared minus 49. Again, that's how you factor a difference of squares. So right now in examples 1 through 4, we're just going to review these two factoring methods, all binomials, and practice factoring those. So for number 1, I have 8x squared minus 12x. It's a binomial, so the very first thing I'm going to do, and this is true again for all factoring problems, is look for a GCF. I have an 8 and a 12, and I know the GCF of 8 and 12 is 4, so I'm going to factor out a 4. And I also have an x squared and an x, which tells me I can also factor out a single x. So my GCF here is going to be 4x, and then I'm just going to think, okay, what's going to be left over when I factor a 4x out of each of these terms? Well, 4x times 2x will give me 8x squared, so I'll put a 2x here, and then 4x times negative 3 gives me negative 12x. So my answer to this problem would be 4x times the quantity 2x minus 3. Number 2, we have 9v squared minus 4. It's another binomial, but there is no GCF of 9 and 4, okay, and you can't factor out a variable either. So for this problem here, you're going to look for a difference of squares. 9v squared is a perfect square. Okay, the square root of 9v squared is 3v. So I know I can put that as my first term in two different binomials. And then 4 is also a perfect square. The square root of 4 is 2, so I know I'll have a 2 here and a 2 here. And that means I just need to put in my signs. When you're factoring a difference of squares, one sign will always be a plus and one sign will always be a minus. So this factors into the quantity 3v plus 2 times the quantity 3v minus 2. Okay, number 3, we have 5d cubed plus 10d. The GCF of 5 and 10 is 5, so I know I can at least factor out a 5. I also have a d cubed and a d, so I can factor out a single d from this problem. Okay, so now I need to think what times 5d gives me 5d cubed. That would be d squared. And then what times 5d is 10d. That would be a positive 2. Finally, number 4, we have 8y squared minus 50. I do have a GCF for this problem. 8 and 50, you can factor out a 2 from each of those. I can't factor out a variable, though, because this 50 doesn't have a variable with it. So the only thing I can factor out is a 2. That's going to leave me with what times 2 is 8y squared. That would be 4y squared. And then what times 2 is negative 50. That would be a negative 25. And then sometimes, even after you factor a GCF, you can keep going with binomials. Notice that your leftover part here is now a difference of squares. 4y squared is a perfect square, as is 25. So that means we need to keep going and factor this part here as a difference of squares. I'm going to bring down my 2, because that's going to stay in my problem throughout. Okay, so to factor 4y squared minus 25, we just have to think about what's the square root of 4y squared. Well, that would be 2y. And then the square root of 25 is 5. So this will give us 2y minus 5 times the quantity 2y plus 5. And again, we have that original 2 that we factored out in front. Okay, so that's a quick review of how to factor binomials. The other types of polynomials we often see when factoring is trinomials. So that would be expressions that contain 3 terms. Okay, and the steps to factor these are a little bit different. The first thing you look for, again, just like all problems, is look for a GCF. So 4x squared plus 8x plus 12, you can factor a 4 out of each of those terms. Okay, but after you try to factor out a GCF, you then need to try these other methods, okay? If you factor out a GCF, sometimes that'll be it, but sometimes you can actually keep going, okay? So there are a few different methods we can use. One method is to look for a perfect square trinomial, okay? And that's when your first term is a perfect square, so like right here, x squared is a perfect square. Your last term is a perfect square, 16 is a perfect square, and your middle term is twice the product of the square root of your first term and your last term. Okay, so the square root of x squared is x, the square root of 16 is 4. If I take twice this, x times 4 is 4x, 2 times that would be 8x. Okay, if my middle term is equivalent to twice the product of this x times this 4, then that means I have a perfect square trinomial. And that means all I need to do is take my square root of my first term x, my square root of my first term, my last term 4, and put it down into this form right here. X plus 4 quantity squared. You can also factor perfect square trinomials using this method down here in number 3. Okay, and this is how we factor a majority of our trinomials. I call these normal trinomials. So this is where, and this hopefully will come back to you from last year, if your leading coefficient is a 1 or a negative 1, okay, you take a look at your constant term, okay, your very end term, and you think what are factors of, in this case 12, that combine to get your middle coefficient, which is 7. And so we know 4 times 3 is 12. If you Add 4 and 3 together, you get 7, and so that means you can factor x squared plus 7x plus 12 into x plus 3 times the quantity x plus 4. Okay? You can also use that method for perfect square trinomials up there on number 2. And then finally, number 4 here, method 4 for trinomials, is if your leading coefficient is not 1 or negative 1, we have what's called slide and divide. That's when you slide your leading coefficient, in this case 2, over to your constant, which is 12, and you multiply those together to get x squared plus 11x plus 24, and then you factor that like normal, and then at the end you need to divide each of your numbers, in this case 3 and 8, by your original leading coefficient 2, okay, in order to factor that. So what I'm going to do is I'm just going to go through these examples with you. Again, these are all methods we did last year, so hopefully it'll come back to you after I do a few of those. Okay, but you've always got these steps up here to refer back to as you need to in this unit. So starting with number 5 here, we have x squared minus 15x plus 36. Okay, so the first thing you might notice is that your first term, x squared, is a perfect square. Okay, so the square root of x squared is x. Your last term, 36, is a perfect square. The square root of 36 is 6. So you might double check this to see if you can factor it as a perfect square trinomial, like method 2 up here. Okay, but when you check that middle term, your middle term has to be twice the product of this number 6 times this number x. Well, if we take 6 times x, we get 6x. If we take that times 2, we get 12x. And our middle term is a 15x. So I can't factor this like a perfect square trinomial. I've got to factor this like method 3, just as a normal trinomial. Since there's no GCF, what I'm going to do is I'm going to think of factors of 36. Okay, so numbers that multiply to get 36, that also combine to get negative 15. Okay, so numbers that multiply to get 36, that combine to get negative 15. So the first thing you want to think of is your signs. Since you're multiplying to get a positive 36, you need to have the same signs. Okay, so multiplying to get a positive 36, we need to have the same signs. And since we're combining to get a negative 15, that means we need to have 2 negatives. Okay, 2 negatives. So I'm going to have a negative here and a negative here. Okay, numbers that combine to get negative 15, that multiply to get 36. Take a minute to think about those. And hopefully you came up with 12 and 3, should I say negative 12 and negative 3. 12 times negative 3 is 36, and then negative 12 minus 3 is negative 15. So that means that this trinomial here factors into x minus 12 times the quantity x minus 3. Okay, for number 6, the first thing you might notice is that there's a GCF. You have 4x squared plus 20x minus 56. And the GCF of 4, 20, and 56 is a 4, so I can factor a 4 out of everything. And that's going to leave me with x squared plus 5x minus 14 when you factor a 4 out of everything. The next thing you need to do is check to see if this trinomial here can be factored further. Okay, so I can tell it's not a perfect square trinomial, so I'm going to look at my negative 14 now. And I'm going to try to think of numbers that multiply to get negative 14 and that also combine to get positive 5. Now, sometimes you won't be able to think of numbers that do this, and so if that's the case, then you would just stop right here and this would be factored. However, we should be able to think of numbers that do this. Since we're multiplying to get a negative 14, that means I need to have a positive and a negative down here in my trinomials. Okay, so we're going to make one of them a plus, one of them a minus. And I need my numbers also to combine to get positive 5. Okay, well, if I think about factors of 14, since they're different signs, that means they need to have a difference of 5. 7 and 2, okay, if you take the difference of 7 and 2, you do get 5. So that means I need to have a positive 7 and a negative 2 in order to combine those to get a positive 5. And so that trinomial there will factor into x plus 7 times the quantity x minus 2, and then don't forget we need to bring this 4 out that we originally factored out. So this would be the factored form of my answer. Okay, number 7, I have 6n squared minus 23n plus 7. There's no GCF for this problem. Okay, this is not a perfect square trinomial either, so that means I need to use, and my leading coefficient isn't 1 either, so I need to use slide and divide. So I'm going to slide this 6 over. I'm going to multiply my 7 by 6. That's going to give me the new trinomial n squared minus 23n plus 42. And now I'm going to factor this like I did 5 and 6. So this will factor into two binomials. We need to find numbers that multiply to get positive 42, that combine to get negative 23. Okay, so we're multiplying to get a positive, so we need same signs, and we are combining to get a negative, so that means just like number 5, we need two negatives. Okay, I need a minus and a minus. Factors of 42 that combine to get 23, think about that for a second. Okay, if you use 2 and 21, those will both combine to get 23, and they'll multiply to get your 42. So this factors into n minus 2 times the quantity n minus 21. Now, don't stop there, okay, because this is a slide and divide problem, so that means at the end here, I need to do my divide step. Okay, if you slide, you must divide, and I need to divide both my 2 and my 21 by that original 6 that I multiplied by. So now this becomes n minus 1/3 times the quantity n minus, if we reduce this, we get 7 halves. Okay, and then the last step, to simplify this, we don't want fractions in our factored answer here. So we're going to take this 3 right here, and we're going to slide it over to the n. What we're really doing is multiplying n and 1/3 both by 3. So this gives us 3n minus 1. And then we're going to take also this 2 down here, slide it over to the n. We're really multiplying again n and 7 halves by 2, and that gives us 2n minus 7. So that would be my final factored answer for this expression. Okay, finally, number 8, we have 9g squared minus 12g plus 4. There's no GCF for this one, okay, but you do notice, hopefully, that 9g squared is a perfect square. Square root of 9g squared is 3g. Also, 4 is a perfect square. The square root of 4 is 2. So let's check and see if this is a perfect square trinomial. 3g times 2 is 6g, and if we double that, we get a 12g, so we do get our middle term. So that means that this is a perfect square trinomial, which, if you recognize that, is pretty easy to factor. This is going to factor into a binomial squared, okay, so something that looks like this. The sign is going to follow our middle term sign, so this will be a negative here in the middle. And all I need to do is take that 3g, the square root of my first term, it's going to come right down here. And then the square root of my last term, that 2, will come right down here. So this factors into 3g minus 2 quantity squared. In case you didn't notice that, you can still factor a problem like this. You can go ahead and slide and divide on this one, and if you slide and divide on this one, just like we did number 7, you would end up getting the same thing. You would end up getting 3g minus 2 times the quantity 3g minus 2. However, if you can recognize that that is a perfect square trinomial and fits those criteria, it's a lot quicker to factor. Okay, so I realize that was a really fast review of factoring. Okay, again, this is all methods we did last year. This is kind of just a crash course in it. Go back and review anything that you need to. Okay, anything that I went through too quickly, feel free to rewind and watch it again. Write down a couple of questions to ask me the next time I see you. And until then, have a nice day. You're all wonderful people. Take care.